you hear me?
Yes.
Okay. So thanks for inviting me to speak to this distinguished audience. I would like to tell you something about display technology and how it should not be commercialized. We now live in a display-centric world. Everything now depends on displays. And the display market is growing quite healthily. Is about 120 billion US dollars last year. The interesting story about this market size is that display is about 1/2 or 1/3 of the market size of semiconductors. You know, IC technology is very important. Semiconductors very important. In fact, if you want to guess, what's the top import goods of China last year, for the last 2 years? The #1 import for China is not oil, not iron ore, but IC. Right? So IC is #1 import for China, and display is number 4 after oil and iron ore display. So it's a very important technology. Now, if you look at all the universities around the world, every university has a strong or semi-strong semiconductor concentration. Every E department has people teaching semiconductors and ICs. But in display, it's just a handful. When we started about 20 years ago, in fact, there were no universities concentrating on display research. So that's obviously a big opportunity. So that's why we started the Center for Display Research about 1995. Now, display is quite interdisciplinary. It combines all the knowledges of optics, electronics, materials, and signal processing, video signal processing, and so on. So the natural home for display research is in electrical engineering. So when I came back to Hong Kong in 1992, after 22 years in the States, I saw this opportunity, and of course, actually, my good friend had something to do with my decision of starting the Center for Display Research, and this Kwok over there. He, of course, founded a display company, Veritronics. So when I came back and we discussed what to do and so on, so the idea of forming a Center for Display Research made sense. So we applied to the industry department at the time called Industry Department. Now it's called Innovation and Technology Commission. So we got some funding, and now we have several faculty members and a whole bunch of researchers. And we are indeed one of the strongest research centers in display in the world, if you count the number of papers and patents and international conference speeches and so on. So some measure of that is the number of SID fellows. SID is the Society for Information Display, and we have 2 fellows of SID in our department, and that is quite unique because the total number of SID fellows is less than 50 around the world. So a lot of patents and publications and so on. One important measure is number of licensing agreements. We have 5 licensing agreements because right from the beginning, we emphasized applied research in addition to fundamental knowledge generation. Excuse for my voice because I have a cold, which started actually last December. Coming back and good for a couple of weeks, and then it comes back. It won't go away. Okay, so what are we doing in the center? So right now, I list a number of the research topics that we are working on. And so first and foremost is thin film transistor technology. Thin film transistors is just another type of transistor which you grow on glass rather than on silicon. And use this transistor to control the display. So it is needed for all high definition displays. And we work both on the new material as well as the device structure. And I'll show you later on that one of our device structure is very promising for driving new generations of displays. Of course, one holy grail for display researcher is the so-called system on glass. Okay. System on glass meaning that the display is on glass and all the electronics will also be on glass. Now we know that IC and the electronics, everything is getting smaller and smaller. Your cell phone used to be this big, now it's so small. Everything is getting smaller. IC, you can pack a billion transistors on a 1 millimeter size chip and so on. Everything is getting small, but the display cannot get small. You don't want a small display, right? So the display has to be certain size, but all the electronics are getting smaller. So it makes sense in the future to have all the electronics to build on the glass. So your computer will be just a glass. Okay, all the ICs can be built on the glass. So we call that system on glass, or system on panel, SOP. So to do that, we need very high quality TFTs, transistors. And to learn how to build ICs using TFTs rather than the normal CMOS transistors. Okay. Another topic we're working on is, interestingly, sitting right next to me, Chen is one of the major manufacturers of the bistable displays and e-paper and e-ink displays. We have some technology that is quite promising for bistable displays. We've been working on that for many years, and we actually have some samples sitting in the lab which we made 10 years ago and still showing the bistable display. We work on something that's sort of green. One problem with LCD is energy consumption. So if we can eliminate the color filter, we can make it 5 times more energy efficient. So that's something we're working on also. And something related to that is to replace polarizers by reflective rather than absorptive polarizers. And that falls into the regime of nano optics. So you can make polarizers using printing technology, and it will not absorb light, but instead it will just reflect the raw polarization. So you can do polarization recycling. One important technology for LCD manufacturing is photo alignment. Right now, LCDs are made by a very good old method, very non-technical method of just rubbing. For LCD alignment, you need to align the liquid crystal. And currently, even the most sophisticated factories in the world, they use a piece of velvet to rub the surface of glass to make the alignment. It's very not high-tech. We have some technology using light alignment. We call it light buffering or photo alignment. We also work on transparent and flexible displays. So let me talk about tech transfer. Tech transfer is one of the major objectives of the Center for Display Research. We emphasize on working on the foremost technology and then transfer the technology to commercialization. And that is in line with our mission of generating and transferring knowledge, okay, and help the economic and social development of Hong Kong. Now, there are 2 ways to transfer technology. One is simply license the technology to another corporation. But there, I'll show you later that there's NIH thing. NIH is not the National Institute of Health. NIH is not invented here. So when you try to introduce technology to another company, especially the large companies with a strong R&D team, they will try to get criticize you to death. So that's very difficult. Another way is to just start a company, right, with the students and postdocs, and license technology to that new startup. But of course, we have to obey the rule that the faculty cannot take advantage of the students, and also we have to obey the 1 day a week rule, and also not have have to declare all the self-interest and so on. Now in California, what they say is that no self-respecting EE faculty doesn't have a startup of its own, and this was told by actually Elijah Blount, which Tony knows. The reason is very simple. In engineering, we do applied research, and the more advanced the research is, the more state of the art it is, the more commercial value it will have. Right? So you're always dealing with commercial value research. And in EE, the barrier or for commercialization is rather small. Right? So it is quite easy to start up a small company dealing with tech development. There are many such success stories. For example, Qualcomm, started by Kirby, who was a professor at USC, and Semiali, professor at UCLA, started Broadcom, and these two, Qualcomm and Broadcom, are the two top IC, fabless IC companies in the world, very famous. And actually, there's a little story about Broadcom. When Broadcom was started, one of Semiali's students was called Aaron Buckler. When I came back to UST in 1992, Aaron came back about the same time. Not came back. I came back, but Aaron came. We recruited him from UCLA, and he was an assistant professor. But then, after a couple of years, Semiali's company wanted him to go back because Aaron is a very bright IC designer. So Aaron went back to join Broadcom, and he took with him 4 of our master students. So he was a faculty here, and he was supervising some master students. So he took the 4 students from Hong Kong with him, went back to Broadcom. When Broadcom went public, so we have 4 UST alumni became millionaires, and they are now living happily in Silicon Valley doing their ventures. So actually, we have quite a few number of alumni in Silicon Valley. So actually, last year, last year, we had Alumni Day in Silicon Valley with a lot of people, students attending, including the 4 guys from Broadcom. So, and also other people. And you'll notice some familiar names, like Pinko and Simon Wong. When Pinko was in UC Berkeley and Simon is still in Stanford, they have very successful ventures working on ICs. So high-tech entrepreneurship is very common in California and also in MIT, Boston. Can we do the same in Hong Kong? Well, the answer is not quite. We're not there yet. So my experience is that in Hong Kong it's very difficult to raise capital to start any company. Now I was a little bit involved in starting a company in New York when I was teaching at the State University of New York some years ago. My friend started a company called Excel Technology, and I was a little bit involved in helping him. And I noticed that it's very very easy for him to get this SBIR grant, Small Business Innovative Research grants. There are many agencies, they have these grants, NSF, EOS, Commerce, Department of Commerce, Department of Defense. They give this 50K phase 1 grants, there's no questions asked, very easy to get. And then if you're successful, you can get phase 2 of 500K. Now, so with these mechanisms, it's easy to start new companies. And in fact, that Excel Technology went public because based on these research grants. But in Hong Kong, it's very difficult. In Hong Kong, there's a government program. ITC has a program called CERO, similar to SBIR. I forgot what CERO stands for. Sorry. It's a poor imitation of SBIR. Why? First of all, they gave you about 1 to 2 million Hong Kong. It's not a grant, it's a loan. And in fact, the company that we started with UST, we had one of these CERO, and they're chasing after us even now to give them back the money. It's ridiculous. So it's very difficult to get financing to start companies. The government is not helping enough. And I have one question. Now, in Hong Kong, the germ one is just there, right? But in Hong Kong, you have this warrants market, this huge market, right? The warrants, options, and so on is a gambling house, essentially. And it's a huge market. Why doesn't the government allow an unlisted company to trade its shares? It's the same thing. Right? If the government does that, I'll get back to that point. In Taiwan, they do. They allow unlisted companies to trade shares and to raise funds through the public sector. Okay, so in CDR, what have we done? We have five licenses to companies. The first license, we have a machine and also a patent on how to measure liquid crystal tilt angle and twist angle, all these fine measurement techniques, which is quite unique. We licensed that to a company, and actually my student was part of the company, and it's a small income, but not really getting anywhere, so it's not really a successful company. We licensed a photoalignment technology to DIC of Japan. DIC is the #3 liquid crystal manufacturer, liquid crystal material manufacturer in the world. We just had a meeting with them. We have 2 meetings with them every year. Just had a meeting with them last month. They said this technology is now being tested by some S company, and hopefully it will be very successful. So UST will be getting a lot of royalty income from yes, I think next year. So that's a success. Now we have a technology of making color liquid crystal display without color filters. We licensed that to a Hong Kong company. They invested time and money into this technology, but unfortunately, it's a failure. So that's a failure. Now, for micro displays and the new AM organic light emitting diode, we licensed the technology to our own startup. So these are our own startups. So I'll talk more about these two. And we have furthermore more technologies coming up, which I'll also tell you something about. Now, micro display is something we actually worked on. The first project we worked on with Veritronics. You all can remember this. Veritronics gave us the first grant, $1 million. It's a big sum. So they gave us $1 million to match with our ITF grant. In fact, the reason why we got the ITF grant was the matching from Veritronics. And it also helped because York was in the advisory board of ITF. So we started working on 1995 on micro display. What it is a display that's made on silicon. Now, you know, on silicon we can make integrated circuits. So we need transistors to control, to have high quality display. So you can, instead of using TFT, just use regular transistor on silicon. And making IC on silicon is a very mature technology. You can just have a design, and you have foundries. You just send your file to the foundry, and they'll just give you back the chip in a few weeks. So it's very easy to make high definition display on a small chip. Okay, so you see the size of the chip compared to a penny. And in this small area, you have 300 by 100 pixels. And that's the picture we got in 1997. 1997, the #1 movie. Right? So let's talk about 3 years to get to this point, and with high resolution nice display. And then took another couple of years to get to very high resolution SXGA display on a chip. So what do you do with such a micro display? It's high resolution, small area. So naturally you want to project that to a large area. So that's the idea of a projection display. So we try to find people interested to make such projection display. No success, even though we have a very nice micro display and about 50 papers to back that up. Okay, so we participated in the HKUST faculty entrepreneurship programs in 2001. So with our own pocket money. Unfortunately, remember 2001, that's the time when LCD TV started to be commercial. Right? So in 2001, there was a good market for projection display using micro display to have a large size TV. But that market dropped like a rock because LCD flat panel display came out. So we were not successful, and we burned up all our money, and so we sold the company to a partner, Hoi-Sing of Taiwan, for very little money. Very little, actually not money, but exchange of shares, very tiny share of Hoi-Sing. And that's a big lesson there. At that time, when we had no money, we sold to Hoi-Sing for the share. They evaluated us based on the money we've spent, not on our IP. Now, we in fact had an IP on micro display. That's very important. And they said, no, we don't evaluate IPs. IP has no value. So I said, okay, we're about to go bankrupt anyway. But now that IP is very important because now all of a sudden Google is interested in micro display. Okay, and in fact, that IP is very important. So that's a big lesson learned. We should insist on evaluating IP. So the first product actually is a Nikon camera with a built-in projector. So this Google Glass may be a big hit. Okay, so let me talk about some future technology, other technologies, not future technologies. Other technologies that we're working on that may have commercial value. One of them is called bistable LC. Bistable LC is imagine writing a display, a scanning display. Normally LCD, you need to keep the voltage, keep the electronics running. Once you turn off the electronics, the display is blank. Right? But bistable LCD, it maintains two states. So even if with no current, no voltage, it will maintain this image. This actually is a bistable LCD, full color, made by this company in the Maldives. They burned 50 million euros, and the company is now bankrupt because they did not follow my advice. They have a technology called bistable TM, and I have something similar but better. The transmission of this display is about 41%, and the transmission of my display is 100%, so 2 times brighter. But it's NIH. I went to France. It's a French company. I went there a couple of times, talked to them, tried to convince them to use our technology. It's NIH syndrome. The researchers, I know them quite well, kept coming back with the nitty-gritty, nitpicking criticisms. So our technology was not used, and they went bankrupt. So these are samples from the market. So we can see the potential, how good that bistable can be. So this is our sample. Of course, it's not as high resolution. So we just need a little bit more investment to make our sample as good as this. So I just told Mr. Chen, and also I've been saying to everyone all the time, professors are only good for making ones from zeros. From 0 to 1, we can do that. We invent things and make very crude samples. But to go from 1 to 1 million takes a lot of investment. Now, manufacturers in Hong Kong, as well as everywhere, they're only interested if the technology can make 1 million. If your technology is ready to be manufactured, mass production, they'll like it, right? 1 million. But from the 1 to 1 million, there's a gap. And then companies should invest in developing this gap. Our government should do that. Okay, another technology is field sequential color. Now, normally LCD is very inefficient. You do all the accounting from the backlight to what you see is only 5 to 8% transmission. Okay, most of the light is lost in this polarizer, 1/2, and also the color filter, 1/4. So if you can eliminate the color filter, eliminate the polarizer, then your LCD can be very efficient. Okay, so how do we eliminate color filter? The way to do that is very simple. Is instead of using color filter, which is side-by-side color, is to use time sequential color. If you can have a backlight that's red, green, blue, red, green, blue. So in in time rather than in space. Your eye will integrate in space as well as in time if it is fast. So you can have full color, but that requires very fast LCD, because the very simple calculation is that your eye has an integration time of 100 milliseconds. So your frame rate should be faster than 480 frames per second, and that is about 2 milliseconds. So your liquid crystal display should be very fast, and we have several technologies patented that can be very fast and can be used for such a field sequential color display. So the idea of field sequential color is you in time very fast, a green panel, a blue panel, red, and then your eye will see the full color. Okay? That's me, my son, about 20 years ago in Colorado. So, in closing, let me make a few comments about high-tech industry in Hong Kong. The government has to do more. Okay? First of all, we'll be talking about this Department of Science and Technology, rather than this IDC. IDC is quite low level in terms of the government structure and has no power. Actually, it's always an embarrassment when people from China comes here. In China, the Ministry of Science and Technology is a high level government office. They come here, the matching government official is very low level. And also, we should allow unlisted stocks to be traded. Okay, I think that should be pushed. We have a lot of finance people. They should consider this. In Taiwan, why Taiwan is successful in high-tech industry? One of the major factors is financing, and one of the major financing innovation they have is for companies to be stocks to be tradable, even though it's not listed. Okay, so of course we need to attract more people to come here to set up shop, and we need more success stories. Okay, thank you.